Mapping diagram, just to recall to your memory, when you do a mapping diagram, you have two sections here. One represents the domain, one represents the range. You need to label it, your domain and your range, so that I know that you know. You're going to list your x values, least to greatest, in your domain. So you're going to say over here, this goes from -2, -1. What do I have? 3 and 4. My range goes 1, 2, 4, 7, 8. And then I just draw a line. My 3 goes to my 2. My 4 goes to my 7. 3 goes to 1. -2 goes to 4. And -1 goes to 8. Is this a function? No, my 3 is going to two different y values. So this guy is not a function. If I had had a 1-to-1 from my domain to my range, it would have been a function. It does not matter if two of your domains go to the same range. It only matters that each domain has only one answer. Vertical line test, even easier. Is this a function? Well, no, it is not based on the vertical line test, because if I draw a vertical line, I cross it twice. So that is basic your mapping, and are these functions questions, pretty much is how that's going to go. Then we get into domains. Identify the domain, and they want it in set notation and in interval notation. Remember, set notation is the little squiggly lines, x such that x equals or does not equal. Interval is either this or this, depending on if it's inclusive or not. So really, I don't care what happens in my numerator here. This is different than the discontinuity questions. This is strictly asking you to tell me about the domain. I could actually combine all of these into one and say, give me the domain and then tell me where it's discontinuous and what type of discontinuity I have, right? Because basically the process is the same, except when you're just talking about domain, you really don't care about the numerator at all. If I was talking about points of discontinuity and what type, you would need the numerator simply to decide if it can cancel or not, right? But for something like this, I don't care about the numerator at all. I only care about the denominator. And so I'm going to say, in this case, where is the denominator 0? That's where any of my problems are in my domain. And so I would factor this guy. Take out your x first. You have x squared plus x minus 6. You can keep factoring him. Factors of 6 that subtract to give you 1. We're going to have a plus 3 and a minus 2. That is my factoring there. And then I'm going to say what makes each of these 0, because zeros in the denominator are my problems. Well, for this guy, 0 makes him 0. For this one, -3 would make him 0. And for this one, +2 would make him 0. Those are all the problems with my domain. And so then I need to actually write those out. In set notation, it would be your bracket like this. And x such that x does not equal these three things, -3, 0, and 2. In interval notation, I would just go from -infinity to +infinity, and I would create little breaks in that where I have those breaks. So I would start at -infinity, which is always open, and I would go to my first one, -3. It does not include -3, so I need an open bracket there. Union with from -3 to the next guy, union with from 0 to the next guy, union with from 2 to infinity. And so I'm simply breaking up my domain into those sections. It includes every single number in between those breaks, pretty much, right? And that's what I'm saying in two different ways. So for something like this, it would be easier to do set notation, right, versus interval notation. For your square roots, which are on the next page, those are actually interval notations are usually easier for those, right? Because I can just go from my number to infinity or to -infinity. So if you do have a square root, you're basically going to say what's inside my root has to be greater than or equal to 0. What's outside my root doesn't affect anything, by the way. Only what's inside the root affects your domain for those next questions. All right. Slope-intercept form. These words should bring to your mind a specific equation. That equation is y equals mx plus b. All right. But because I don't have my m or my b, I've got to find my slope, and I really need to then work out my slope-intercept using usually point slope is what we typically use. So the first thing I need to do is find my slope, which is my m of that equation, which is y2 minus y1 over x2 minus x1. So you do need to know your slope equation. Subtract your y's over the subtraction of your x's, all right? And you do need to work it out. -3 minus a -2 is -1. -2 minus 3 is -5. Negative over negative is a positive. So positive 1/5 is my slope. Positive 1/5 is my slope. I'm not done yet. They want the whole equation. I just found the m piece of it. I need to find the y piece of it, right? Typically you use point slope to do this. Either of these will work. I'm just going to use the first one. So from here, you probably want to use your point slope. And just a reminder, your point slope equation is y minus y1 equals m x minus x1. You could plug it back into your slope-intercept and just solve for b if you want to, and then plug everything back in. This will just get you straight to it. So I have y minus my y1 equals m that I just figured out, x minus my x1. And then to get it in slope-intercept, just algebra here, right? So we're just going to move the numbers over. So this is y plus 2. Distribute your 1/5. So we have 1/5 x minus 3/5. Subtract that 2 over. 2 over 1 is 10 over 5, right? So y equals 1/5 x minus 13/5. And that is my answer. So I am done there. Oh, I don't want that guy. All right, any questions on that one? The graph as well as the slope. When you have it in standard form, so y equals mx plus b, you kind of are handed some of these, but when it's in standard form, you really have to just either plug in a 0 or remember that it's going to 0 out and divide. So my x-intercept is what happens when I 0 out the y piece of it. If I 0 out the y piece of it, I just get x equals -2. So my x-intercept is going to be -2, 0. My y-intercept is what happens when I 0 out the x. Well, if I 0 out the x piece, I get -2y equals -2. Y equals 1. So my y-intercept is going to be 0, 1. My slope is always going to be my -a. So if this is ax plus by equals c, my x-intercept is always going to be c over a. My y-intercept is always going to be c over b. That's how it's always going to work out. And my slope is always going to be -a over b. Because if I move that over and put it in slope-intercept form, it's going to negate the a and divide by the b, right? And so in this case, my slope is going to be -1 over -2, which is just 1/2. That is my slope. And so I've really solved for the first three pieces here: x-intercept, y-intercept, and slope. And when you graph it, you can literally put your x-intercept on the x-axis, your y-intercept on the y-axis, and then you just connect the dots. So for this particular graph, my x-intercept, that's right here. I go to -2 on the x-axis. My y-intercept was +1. I go to +1 on the y-axis, and then I just connect the dots, and that is my line. That is the graph of my line. Parallel lines have the same slope. Perpendicular lines are negative reciprocals. So negate and flip your slope, all right? For this one, you are still going to use your point slope. So you are going to use your y minus y1 equals mx minus x1. They hand you your x1 and your y1. So they hand you your x1, they hand you your y1. They've also given you a reference line parallel to this line, perpendicular to that line. And so they technically have given you your m as well. If it is parallel, your m is going to be the same. So your slope is going to be whatever your m is, in this case 6. All right? For perpendicular, they've also given you your x1 and your y1. But your slope, you're going to do a couple of things. You're going to flip him. So instead of 1/3 for a perpendicular line, you will flip it. It will be 3. And instead of negative, it will be positive. So whatever it was, you're going to negate it and you're going to flip it for perpendicular. And then the process is the same. You are then going to plug it back into this guy and get the y by itself. So like for this one, you would say y minus my y1 equals this m, 6, x minus my x1. And of course, you will want to simplify this as much as possible. So I'm going to say y plus 3, this is plus as well, equals 6x plus 6, subtract my 3 over, y equals 6x plus 3. That's my parallel line. I would do the same thing for perpendicular. Y minus my y1 equals this m, this perpendicular m, 3x minus my x1. You'll notice that I am not using anything else from those reference lines. I don't care about that -5. I do not care about that -2. I only care about the slope of that reference line. All right? And then I'm going to continue. I'm going to distribute that 3. So I have y minus 3 equals 3x minus 3. I'm going to add that 3 over, which gives me y equals 3x plus 0, but you don't have to worry about the plus 0. And so that would be my mx plus b for that one. So you're using those for really all of your linear equations. You'll notice that you're using the same equations over and over and over. All right. All right. Here is the same process of when you did domain for me, okay? The only difference is for the first set, I'm handing you a number and saying, is it continuous at this specific point? And if it's not, what type of discontinuity, okay? So you have a couple types, or technically 3 types. So the first 2 typically deal with a rational function, meaning you have a denominator issue, okay? Somewhere the denominator is 0 for these 2. You have a point discontinuity and an infinite discontinuity. If the denominator is 0, it's going to be one of these 2 for a function like this, a rational function. And the way you decide is, can I cancel it out with something in the top? If I can cancel it out with something in the top, it is point. It's called removable. So if I can remove it or cancel it, it is point. Okay? If I cannot cancel it out, it creates an asymptote and it is an infinite discontinuity. It goes off to infinity. So this is non-removable. Non-removable, or I cannot cancel. Cannot cancel. All right? I have handed you 2 points here. All right? So what I'm going to do here is I am going to just factor this denominator. The numerator here is already factored as much as it can be. So I'm going to factor this. The only thing I can do is take out an x. X, and then x minus 4. The first thing I have to decide is, do those 2 points cause a problem, right? Well, does 0 cause a problem? Yes, because if I plug a 0 in, this guy is 0, and my denominator is 0. Does 4 cause a problem? Yes, 4 does cause a problem, because if I plug in a 4 there, that is 0. So my function looks like this. I have negative x over x, x minus 4. We know both of those are discontinuities. We just need to figure out what type. All right? So for the 0, this is my problem with my 0. Can I cancel it? Well, yes, actually, I could cancel my problem with this numerator. I canceled the 0. What type of discontinuity is it? Point. So I have point at x equals 0. The 4 caused a problem here. Can I cancel a 4? No, I cannot. That is infinite. At x equals 4. And that would be my answer. This is my answer for this. All right. Now the next one I don't give you. I just say, is it continuous? So the first question is it continuous? That's a yes or no question. You're going to determine if it's continuous. All right. If it's continuous, you are going to write the word continuous and you are going to move on to the next question because you are done. But if it is discontinuous, I say classify it. By that I mean I want point infinite, or in this case, you may also have a jump. And so this is the most common type of jump. So you're going to look for a piecewise function. Now, I will say there are cases where piecewise are point. All right? Piecewise that are point will actually pull out a point. And they'll say, for everything not equal to 4, use this parabola. And when it's equal to 4, here's what you're going to use. That's a point. They legit pulled out a point and said, for everything except this point, use this function, all right? But for something that looks like this, they've given you 2 separate domains, less than or equal to 4 and greater than 4, all right? You still have to decide, is this continuous? The way you decide if it's continuous for something like this is you plug that 4 into both pieces. If it's the same number, it's continuous. It's going to come to that piece. It may change, and it may look like a line here instead of a parabola, but it's going to be continuous. If they equal 2 separate things, then you're going to have a piece of a function, and then it's going to jump, and you're going to have a piece of another function. And that will be a jump discontinuity. But you still have to determine whether it's continuous or not. So I'm going to plug it in here. 2 times 4 minus 8. What do I get there? I get 0. I'm going to plug it into the bottom. Negative 4 plus 7. What do I get? 3. That means this little function's trucking along on a line. That's 2x minus 8. It's a linear equation. It's going to get all the way to 4. And then at 4, it's going to be 0. Right? But after 4, it's going to jump to this new linear equation. Right? And at this new linear equation, it's going to be at 3, open circle. And then it's going to be a line, technically a line. So and from your perspective, it would have been a positive slope. Then it's going to jump from 0, open circle, and then it's going to be going down, a new line. This is a jump discontinuity. So you would tell me this is a jump at the point x equals 4. So when you get to 4, on the x-axis, this particular function will jump. It will jump to a new function. And so when we get to graphing those piecewise functions, that's what you'll start seeing. You'll start seeing this regular function. Oh, we're going to jump. We're going to be a new function. We're going to jump. We're going to be a new function. All right. So the handout that I gave you has all the parent functions on it. As we are, you need to look for key things here. This one has a cubed. That should take you to one of your parent functions. 38 has a square root. That takes you to one of your parent functions. Absolute value, if it's squared, quadratic is a parabola. So you should be able to see those things and say, I know what the parent function is here. And if you know the parent function, then you can graph the changes in the parent function, all right? So your standard cubed looks like this. It's this little guy. He's kind of like that. I drew him a little bit fat, I guess. So my -2 is going to stretch it. He's going to be a little skinnier. It's also going to flip it. So he's going to go the other direction, okay? So instead of going from down to up, he's going to go from up to down, right? That negative is going to flip it and it's going to stretch it, make him a little skinnier, all right? So when I look at this first part, I'm going to say, well, he's going to be flipped and he's going to be a little skinnier. That's what that -2 tells me. Had it been a +2, he would have just been skinnier, not flipped, okay? The inside of it tells me my left and right movement. Opposite of what you would think. You would think a -2 would move you left. A -2 will move you right, okay? If I had had anything on the outside, that would have been my up and down movement the way you think. Plus is up, minus down, okay? And so once you figured out my parent function, am I stretching or flipping, and am I moving it, then you can sketch the graph. And sketching the graph just requires that you do just that. I'm not going to be measuring with a ruler to make sure you did everything. What I am going to be looking for is, did you go over to the right 2? Did you reverse this guy? See how he went from this way to now this way? And he should be a little skinnier, but I'm not going to be real specific on these cubes, right? I mean, I'm not going to be like, oh, he was too fat, he was too skinny. You know, if you have an absolute value, you do want to pay attention to that slope because you can be very exact with like an absolute value, right? Parabolas, you can be a little more exact, but some of these you are just sketching. Like your square roots, it's really hard to note that it is either stretched or skewed, but you certainly can flip those correctly, okay? So this is a sketch. I'm looking for movement, and is it the right direction, really, is what I'm looking for here. Vertex movement, and did you do your direction correctly? So this says identify the parent function. I will take the identify 2 ways. I will take the primary function, or you can call it what it is, like quadratic, right? So you can tell me if there's a description of it. You could say absolute value, right, if you wanted to. I personally, being a math person, if I were to do this particular one, I would identify the parent function by just giving you the parent function like this. That's how I would do this, because I don't want to write a lot of words, as we discussed earlier, right? Now, a couple things with this guy. He flipped, right? So the standard parent function looks like this. He flipped, which means I am going to put a negative on the outside of that guy. He also moved. He would normally be right here. He moved over 2 and up 1. That means inside my parenthesis, or inside my function, I have movement, and outside of my function, I have movement. So I'm going to take this parent function and I'm going to change it. I'm going to put a negative to indicate he flipped. He moved right 2. Remember, it's opposite of what you think. So I'm going to say x minus 2. That's my right movement. He moved up 1. That's what you think it would be, plus 1. That is my new function. And so this is what your actual function will look like. The top one is your parent function. So this combines all the parent functions that you've done so far, pretty much. Like, it just throws them all into one graph. That's what a piecewise function does. It takes all of those pieces and it gives you a little bit of each one, okay? And so for this particular one, a lot of times you can sketch it and then erase it, if that makes sense. So like for this first piece, I would say, okay, this is a radical. So normally he would look like this. Inside we have a negative, so he's going to look like that. I'm not extremely concerned about that 3 that you stretched it, made him fatter or whatever. as long as you know that the direction at least is different. So if I were doing this one, I would say, well, normally he would look like this. Now, what you can do to make sure you're within your function, so normally he would do something like this, okay? But I know it actually is everything below -2, okay? So what I can do is I can plug in a -2. So I know that at -2 is where that part of my graph stops. Even though that's what he would normally look like without those limitations, it's only going to go to that yellow line there because that's where it stops. I can also plug in a -2. So I'm going to say -3x goes all the way to -2. So I'm going to say -3 times -2. That's the square root of 6. I don't know the square root of 6 is an irrational number, but I do know it's in between the square root of 4 and the square root of 9, which is in between 2 and 3, right? Everybody understand why I know that? Okay. Square root of 6 is somewhere between the square root of 4, 2, and the square root of 9, right? And so I know my y value is somewhere between those numbers when I get to 2. You'll notice that I'm a little below that. So you may want to, shift that up a little bit. So you may want to say, well, it's somewhere in between here. So he probably should have gone up a little bit sharper when I did this. And so this is why you're going to want to sketch, and you're going to say, well, I'm going to actually move this guy here. He probably should have been up here somewhere. And then I'm just going to go that direction with him. It is inclusive or equal to. So I'm going to put a closed dot there, and that's my piece of it. So normally he would go all the way to my origin, right? But he's not, because it defined it by this little stopping point. At this point, I switched to a new function. All right. Another way to write this function, and I'm going to do it in a different color here, is 1/2 absolute value of x. All right. Well, what would he normally look like? Well, he would normally be absolute value with a slope of 1/2. So he would normally look like this, up 1 over 2, up 1 over 2. So normally he would do this, and that would be my function. But he doesn't go that far. He stops right here, right? He goes from -2 to +4. So his lines actually look like this too, -2 to +4, okay? Now you can plug it in. You can say, well, let's see what happens at -2. 1/2, oh, let's not do it. 1/2 -2. Well, that's 1/2 times 2, which is just 1. So he at -2 will be at 1. Does it include that point? No. It's just a less than or equal to, not a less than or equal, or greater than, not greater than or equal to. So I'm going to get rid of everything up to that point. Make that smaller. Everything up to that point. And at that point, I'm actually going to do an open circle there. All right. He also goes all the way to +4. So I'm going to do the same thing. I'm going to say 1/2 +4. 4 times 1/2 is 2. So at +4, he should be about here at 2. And he's not going to go any more past that. So he's actually going to stop there. And it is less than 4, not less than or equal to. So I now need to do the same thing here. We have an open circle right here. All right. I'm done with that piece. I went from -2 to +4. The last piece of it is a line. All right. Now, because it's a line, I don't even have to really sketch the parent function. I can just sketch the end point and then another point, because as long as I have 2 points on a line, I have my line, right? For this piece of it, it is greater than or equal to 4. So I'm going to say what happens at 4. So I'm going to plug in a 4 plus 1. -4 plus 1 is -3. So when I'm at this point here, I'm actually down at -3. So I'm going to go down to -3. A couple ways you can do this. You can choose another point, 5, or it's a negative slope, right? -1 slope. So you can literally go down 1 over 1, right? And you can just, I have 2 points here, and this guy is going to do this to infinity. And because it was or equal to, I'm actually going to leave this guy closed. All right. Those are my 3 pieces. I am done. So you're literally taking those parent functions and doing a piece of each parent function. changed however it tells you to change it. There are two things that we looked at with quadratics. I'm going to make those a little bit bigger if it will let me. Actually, let's do this. Let's make this guy, and then we'll do this guy here. I'm just going to make it a little bigger so we can see it. All right, so first one, this one, and then we'll put him over here. So what's the difference in these? Well, the difference in these is that you have it in standard form or you have it in vertex form. This first one is standard form. So this guy's standard form, and you can see what the graph looks like. Yours obviously will be blank. But these are 4 points. Please don't leave a 4-point question blank on my test. There's about 22 questions. So that means you have about 26, 28 points, 4. I mean, I know I'm a math teacher, but we don't leave 4 blank, right? So axis of symmetry, vertex, y-intercept, and then sketch the graph. So for vertex form, your axis of symmetry is going to be what? Negative what? B over 2a, right? Negative b over 2a. And then to find the vertex, we're going to take that guy. That will be my x point, negative b over 2a. And I'm going to plug that guy in, f of negative b over 2a. That will be my y value of my vertex. And then my y-intercept's really easy. That's just 0c. Okay? And so that's pretty straightforward. Negative b over 2a yields a 3. So you'll notice that my axis of symmetry is right here at positive 3, right? 12 over negative 12 over negative 4, positive 3, okay? So I would write axis, not like that. I would write axis then is x equals 3. Plug that 3 in, you're going to get negative 4, which is why my vertex ended up being here. So I'm going to plug it in. I'm going to say negative 2, 3 squared plus 12 times 3 minus 22. That's going to be a negative 4. So my vertex is a point, and it is 3, negative 4. And that's why this is right here. It's pointing down. Well, there's 2 ways you will know it's pointing down. The first way is there's a negative right here. Okay? The second way is my y-intercept, which is the third thing I asked for, is my c. 0, negative 22. So obviously it's going to be way down here somewhere, right? Which means I'm going to be negative. Now, the problem here is that I don't necessarily know how to sketch the graph if I don't know something to mirror it. So you can always pick a point, or, you know, you can think about your slope being negative 2, right? This kind of represents your slope. So if you go over 1 and down 2, you'll see that guy there. Over 1 and down 2, you'll see these two kind of represent a little bit of slope if you were doing it that way. It's not technically slope, but it's a little bit like that to get 2 points if your y-intercept is off the graph. If it is on the graph, plot your y-intercept and mirror him to your axis, okay? That is if it is in standard form. And so if it is in standard form, you're going to do those things. The other way I could possibly give it to you is vertex form. Vertex form's even easier. This is your H, this is your K. Your axis is just x equals technically negative H. I mean, technically it's actually just H, but you have to negate it. So the opposite of that, this is negative 1, so my axis is positive 1, and you can see that's where they graphed it. My vertex for this form is going to be negative H and K. So in this case, a positive 1 and a positive 4, and you can see that's where that vertex is. The only thing you really have to calculate here is your y-intercept, and it's how you always calculate y-intercept. Plug in a 0, right? So plug in a 0 here. So y-intercept is going to be 0 and then f of 0. What happens when you plug that in? So -2, 0 minus 1 squared plus 4. 0 minus 1 is -1. -1 squared is 1. 1 times -2 is -2. -2 plus 4 is +2. You will see, there we go, +2 was my y-intercept. Because it's on my graph, I could just mirror over here and do a 1 away from my axis there. And then sketch it. Should be a parabola. All right. Standard form or vertex form. Those are your options for quadratics. All right. We good? We then solved quadratics, page 10. We solved them 2 ways, factoring and quadratic formula. Factoring first, it has to be equal to 0, which means I need to move this guy over. And I get 5p squared plus 13p plus 6 equals 0, all right? Now, to factor, if you don't just automatically pair them up, you can use that, what I don't know if they call it the rainbow method. I don't know. You just go across here. 5 times 6 is 30. I am looking for factors of 30 that add up to 13. 3 and 10, right? Then I am going to rewrite this guy and replace that 13p with 3p and 10p. 5p squared plus 3p plus 10p plus 6. So I kept the first and last the same. I replaced the center guy with those, and then you will factor by grouping. Take out just a p to begin with here. So I have 5p plus 3. Take out a 2 in the second group. I have 5p plus 3, which, by the way, if it's factorable, is how it should always work. So then my factors are 5p plus 3 and p plus 2. Those are my 2 factors. Set them equal to 0 and solve. Subtract your 3, divide by 5. So p, subtract your 3, divide by 5, so -3/5 for that one. Subtract your 2, -2. Those are your answers. Okay? So that's a factoring method that we've done in the past, right? Multiply across, factor by grouping. The other way that we solved quadratics was the quadratic formula. Very important that you know the quadratic formula. -b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. It also has to be equal to 0 and in standard form, okay? So that means move that 2v over. You have 9v squared plus 2v minus 3. So then you have your a, your b, and your c. And then you just plug it in. -b plus or minus the square root of b squared minus 4 times a times c. Make sure you put that negative there, all over 2 times a. And then you're just doing order of operations. Like, that's legitimately what you're doing. So you have, don't forget your positives and negatives rules here. So we have -2 plus or minus the square root. I have 4, and then it's a negative and a negative. So this is actually going to be plus. And then I have 4 times 3, 12 times 9 gives me 108, hopefully. All right, which is not it's not going to be a perfect square, but that's okay. Reduce it as much as possible. -2. You're going to add your 4 there. Don't forget your plus or minus over 18. Factor it out. I mean, if you don't know, if it's not a perfect, just factor him. 2 and 56. 2, is it a 20? What's underneath there? We should be able to get a 27. Yeah. What am I doing? Yeah, but did I do it right? I don't know. There we go. Okay, there we go. There's my math. There you go. Always check your factoring. All right. 28. There we go. That makes more sense. All right. 4 can come out, 7 can stay in. So -2 plus or minus 4 squared is 7 over 18. Can I reduce? Can I reduce? Yes. What comes out of all 3 of those? 2 comes out of that, 2 comes out of that, 2 comes out of that, 1, 2, and 9. So my final answer is going to be -1 plus or minus 2 square root of 7 over 9. All right. Equations are literally what it tells you to do. The only thing I want to point out is that your composition and your multiplication look very similar. Don't confuse them because it will be all mixed up. It's not going to separate it out. So these are actually both composition. If it were multiplication, it would just be a dot. It would just look like that. Okay, that means multiply. And then the open circle means composition. Okay, so pay attention to what it's telling you to do. Okay, I only say that because that's a common mistake when I give this quiz or test. Okay, if it's addition like this, it literally just means take G and add H. Combine your like terms, x and 4x. -4, -4, you're done. Like, add your functions.
You don't do anything with the x.
You can't here because it didn't. Now, if it had a number here, then you would plug a number in.
Okay.
So if it had said g plus h of 3, plug in a 3 when you get that answer. Yeah, so like the bottom half of this page, or bottom, whatever it is, 1, 2, 3,
Right.
2/5, bottom 40% of it, just means at this point now plug a number in. So, but if it doesn't have a number, your answer is a new function. Okay. Composition, that means put one in the other. G of f means put f inside of g. So I'm going to write g instead of an x, I'm going to write f. And then I'm going to finish g. So this is 2x minus 5. So that means I need to distribute my 2. 6x cubed plus 10 minus 5. That is 6x cubed plus 5. That is my answer as well. That's supposed to be a 3. Okay. So composition just means put one inside the other. All right. The bottom of this page then puts numbers there, which means do whatever it tells you and put a number in. So like for this one, g of f, put f into g. So we're going to write g instead of x. I'm going to write my f, right? Distribute 2x squared minus 8 plus 1, 2x squared minus 7, but they want me to plug in a 10. So that means I need to go in here and plug in a 10. So 200 minus 7, well, that's 193. When there is a number here, your answer is a number. When there is a variable here, your answer is a function or a new description, a new definition of what you're talking about, okay? You're basically choosing a t. So if t equals -2, if t equals -1, and they actually, I probably, since I know this guy, although I have an advantage, -1, t equals, I would probably do a 0 and maybe a 1 as well.
We also do another 2.
So when I plug a y in, it's just going to be this guy, so that is my y. And so I have 1, -3 right here, right? Does everybody see how that works? So you have a picture of kind of what's going on by picking these points. If I plug in a -1, right? You're actually going to get multiple things when you do this. That's how they got the top half of it. And so these t's represent what you've chosen, and you get an x and a y value by plugging it in. It'll depend on what you choose. I mean, it'll depend on which t's you choose. And I will strictly base it off of the numbers that you chose. So let's say your numbers don't give you a picture of a parabola. That's okay. I will trust that what you chose, you sketched accordingly, as long as you knew to plug it in and get x, y values, right? So don't worry that you're choosing the wrong ones. I'm only going to base it on, did you know to choose 4 t's? Did you know to get ordered pairs from the t's that you chose? And did you correctly plot your ordered pairs?
So it doesn't matter which numbers.
So I will not say, oh, they didn't figure out it was a sideways parabola. I'm not going to do that. I'm just going to make sure you picked 4 and then you got an x and y value for all of those. Okay? Does that make sense? And so as long as you were able to get an x and y value for all of those, you're going to be good. So, but when you do that, you're going to see something develop. Now, like, you know, if you chose a 1, it's going to give you this guy right here. So you may start to see a change in it when you do that. But it's okay if you don't. As long as you pick these, any 4, and you get 4 ordered pairs, and you correctly sketch the 4 ordered pairs. I will not say, well, you didn't recognize it was a specific shape, okay? I'm only concerned that you understand X and Y are based off a 3rd variable, and you have chosen 4 numbers for that 3rd variable.
Is it always going to be like that?
Not necessarily. Inverses, you need to find the inverse and be able to tell me. Finding the inverse, I actually made sure on your test it was only X's, by the way, not N's. So the first thing is to switch your X and Y. This technically represents Y, that technically represents X. So your test will only have X's. It will not have crazy variables because I don't like them. So switch X and Y means make this your X, make this your Y, and then solve for Y. How do I get rid of a root? Well, I just raise it to the power. So now I have x cubed equals y plus 1. Subtract 1. X cubed minus 1 equals y. Typically, you replace this guy with your indicator that you have found the inverse, you know, that it's not the same original function. But this is what I'm looking for here. That's your inverse. Switch X and Y, solve for Y. Those are literally your steps. You are to switch X and Y, and then solve for Y. That is what you do to find inverse. When it says, are they inverses, use composition to tell me that and explain why or why not. I want you to do a composition of these 2 functions. It does not matter what order you do it in. The answer will be the same, yes or no. Whichever it is will be the same. So if I do a composition here, like let's say I do h of f, I'm going to say 1 over 7. Instead of x, I'm going to write 7x plus 3. All right? And then minus 3/7. So 1/7 x minus 3/7. I really just copied this guy and plugged in 7x plus 3. And then I need to simplify it. So I need to distribute this guy. I'm going to get an x plus 3/7 minus 3/7. These will cancel. I'm going to get just x. Your answer then will say, yes, they are inverses. Yes, inverses. And then your explanation will be what? Because the composition equals x. Or you could say f of h. Yeah, whichever way you did it, it will be the same. F of h equals x, or h of f equals x, whatever you did in your proof, right? So you're going to tell me, yes, they're inverses. And they're inverses because the composition equaled x. Now let's say you did not get an x there. You would say, no, they're not inverses because the composition does not equal x, right? So your explanation is literally, I want to know that you know what you have and why you have it, pretty much.